Three labs just shattered the limits of AI. One now solves complex medical puzzles with 94.6% accuracy, another runs advanced reasoning on your phone, and a third claims to cut training costs by 70%. This is not hype, it is the real arms race fueling breakthroughs you need to see right now. Are you ready to discover why these advances could change everything? And what is really driving this explosive leap? OpenAI's latest model, GPT-5, is not just another chatbot upgrade. It's a leap into extended reasoning that feels like a new species of digital intelligence. Engineers say it can hold a problem in mind, find, break it down, and orchestrate tools step by step instead of just spitting out the next likely sentence. On the AIME 2025 math benchmark, GPT-5 scored 94.6%, a score that once belonged to top human competitors. For coding, it passes real-world tests like SWE Bench Verified at 74.9%. But the most dramatic change is in reliability. GPT-5 produces about 45% fewer factual errors than GPT-4o on web search tasks. In practical terms, that means fewer hallucinated facts and more trustworthy answers, especially on complex, open-ended questions. The difference is not just in the answers, but in how the model thinks. It can chain together multiple steps, call external tools, and adapt as it goes. What used to be a clever autocomplete now acts more like a research assistant, proposing plans, checking its own work, and even flagging uncertainty when it is unsure. For anyone who has tried earlier models and felt the limits, random errors, shallow logic, and easy-to-break conversations, this new wave feels fundamentally different. The numbers back it up: measurable jumps in reasoning, real drops in hallucination, and a growing sense that AI is crossing the line from answering questions to solving problems. Gemini 3 does not just process language. It is designed to sense the world like a unified brain. Google DeepMind's latest model family is built to see, read, listen, and even interpret video, all within a single system. Gemini 3 Pro and its Deep Think mode have set new records on some of the toughest benchmarks in AI, scoring 41% on humanity's last exam, a test meant to stump even PhDs, and 93.8% on GPQA Diamond, which demands graduate-level science reasoning. But the real turning point is not just in raw numbers. Gemini models can run not only in the cloud, but also on the edge, right on your phone. Gemini Nano, a distilled version, now powers features like live transcription, smart replies, and instant summaries directly on Pixel devices. That means AI that can see and hear is no longer locked in a data center. It is in your pocket, working privately and instantly. Google's leadership, from Demis Hassabis to the DeepMind team, is betting that true intelligence will come from connecting every sense, not just every sentence. In this new era, the difference is not just what AI can answer, but how closely it can perceive and interact with the world around you. DeepSeek's R1 didn't just compete on intelligence, it crashed the price floor for frontier AI. At the heart of R1 and its open sibling R10 is a sprawling 671 billion parameter mixture of experts model, but only 37 billion fire on any given token. That is not just technical trivia, it means the system runs with a fraction of the compute, slashing energy and hardware needs. DeepSeek claims it trained R1 for less than $6 million, relying on domestic H800 GPUs rather than the export-controlled H100s that power Western labs. Independent analysts cannot verify the exact bill, but most agree R1's training cost lands somewhere in the low single-digit millions, a 70% drop compared to the rumored budgets for OpenAI or Google's latest giants. This is not just about saving money. When a model with frontier-level reasoning can be built on a budget, the entire map of who can play in the AI race changes. Suddenly, advanced reasoning tools are within reach for smaller companies, new countries, and anyone priced out by the old regime. For global tech strategists, DeepSeek's efficiency is a warning shot. The barrier to entry is falling, and with it, the concentration of power that has defined the last wave of AI. The question is not just who builds the smartest model, It's who can build it fast, cheap, and everywhere. Inside hospitals and research labs, AI is no longer just a research project. It is powering real breakthroughs for patients and doctors. In cardiology, AI-driven imaging tools are now scanning heart tissue with a precision that once took hours of manual review. One system, using a catheter-mounted camera and deep learning, can spot hidden artery risks in seconds, cutting diagnosis time by half and catching problems that standard scans miss. In semiconductor factories, engineers rely on Raptor, an AI system that inspects chips with high-resolution X-rays. The numbers are hard to ignore. Raptor detects microscopic defects with 97.6% accuracy, a leap that means fewer faulty chips and less waste. Meanwhile, brain-computer interfaces are moving from science fiction into everyday clinics. A wearable BCE, tested with paralyzed volunteers, lets users control a robotic arm or a cursor up to 4 times faster than before, translating brainwaves into action in real time. These are not just demos. They are proof that AI is delivering measurable wins, from faster cardiac diagnosis to more reliable hardware and new hope for patients who once had none. AI labs are now releasing new frontier models on a 6 to 12-month cycle. That speed is far faster than most laws or oversight can adapt to. Regulators and cybersecurity researchers warn that this pace leaves critical gaps. In Washington, chief executive officers from OpenAI, Google, and others have offered only voluntary safety commitments at White House roundtables, promising red teaming and transparency, but stopping short of legal obligations. Meanwhile, the systems themselves are growing more complex and less interpretable. Even leading engineers admit that no one can fully explain why a model gives a particular answer, or what it might do if prompted the wrong way. That makes model behavior unpredictable. Security flaws like prompt injection attacks have already shown how easy it is to trick even the most advanced models into leaking data or bypassing safeguards. As AI moves from research to real-world deployment, the speed of release is outpacing the ability to audit, understand, or control what these systems actually do. The result is a widening gap between what is possible and what is governable, raising hard questions about whether our institutions are prepared for technology that evolves at the speed of code. AI now solves problems once thought impossible. It moves at breakneck speed. As models outpace old limits, the real challenge is keeping our values as sharp as our technology. What matters most now?